Welcome to The Explainer. Today we're diving into the fascinating world of unsupervised learning. We're going to uncover how machines learn to find hidden stories in data, all on their own.
So just imagine this for a second. You get this giant box, right? And it's filled with old family photos. But here's the catch. No tags, no names, no dates. It's just a chaotic mess of images. What do? I mean, how would you even begin to organize that? Well, you'd probably start looking for patterns, wouldn't you? You'd group photos by who's in them, or maybe where they were taken. You'd be creating structure where none was given to you.
Well, in the world of machine learning, that's pretty much the core difference between supervised and unsupervised learning. See, supervised learning is when your data is all neat and tidy. Everything's labeled. It's like getting a test with an answer key. But with unsupervised learning, nope. The algorithm gets that messy, unlabeled box of photos we just talked about, and it has to figure everything out from scratch.
So when you boil it all down, unsupervised learning is basically giving a machine a really complex puzzle, but with a twist. There's no picture on the box to guide it. It has to discover all the patterns and structures completely on its own. It's truly the art of finding order in chaos.
Okay, so how do we actually do this? How do we start making sense of all this chaos? Well, our first tool, and honestly it's probably the most common one out there, is called clustering.
And the goal of clustering? It's really simple. It's just to find the natural groups that already exist in your data. It puts similar things together into these little buckets or clusters, all based on what they have in common.
Okay, let's make this a bit more concrete. Take a look at this. This is data from 200 mall shoppers. On one side, you've got their annual income, and on the other, you have what's called a spending score, basically from 1 to 100. Right now, what does it look like? It just looks like a big cloud of dots. I mean, where do you even start with that? But check this out. We apply a clustering algorithm, and boom, just like that. The machine automatically sorts that big cloud into 5 totally distinct color-coded groups of shoppers. And the amazing part? No human told it what to look for. It found these segments all by itself. And this is where it gets really interesting, because these clusters, they tell a story, a really powerful one. You can see the careful group, high income but low spending, and then you've got your target group, high income, high spending. This is the key insight. A business can stop marketing to a faceless crowd and actually start creating super targeted campaigns. They can offer those fancy luxury deals to the target group and maybe some budget-friendly options to the careful group. It makes everything they do way more effective.
Okay, so that's clustering. Let's move on to our next tool. Because sometimes the most important piece of information isn't what's in the group. It's the one thing that's way outside of it. The data points that just don't belong.
And that's the job of something called outlier detection, or you might hear it called anomaly detection. Its whole purpose in life is to find the exceptions to the rule. The real odd ones out that just break all the patterns.
A good way to think about it is this. A lot of the time, the most valuable insight comes from the one piece of data that makes you stop and ask, wait, why? Why is this one so different from everything else?
Let's take real estate, for example. In any given neighborhood, most of the houses are going to cluster together pretty predictably based on their size and their price, right? Makes sense. But an outlier detection algorithm, it can instantly spot that one property that's way out from the main group.
And here's why that's so important. That outlier, it's probably not a mistake in the data. It's a signal. This house is huge for its low price, and that could be a critical clue that something's up, like maybe it needs massive, expensive repairs. So finding that outlier means you found either a huge opportunity or a huge risk.
All right, our third tool is a little more abstract, I'll admit, but it is incredibly powerful. This one is all about finding important ideas or concepts that you can't just measure. And we do it using something called a latent variable model.
I mean, think about it for a second. Some of the most important things we want to know, like brand loyalty or customer satisfaction, you can't just measure those with a ruler, right? They're concepts. We have to infer them. We have to uncover them by looking at the things we can actually measure. And this is a perfect example of how that works. You start with stuff you can observe and measure, no problem. Things like income, how many hours of sleep someone gets, their exercise habits. Then, the model is smart enough to group these into related themes. These are our latent variables, like physical health or social life. And once you have those, you can finally start to construct and even measure that big, invisible concept we were after, overall well-being.
Okay, so let's recap. We've got 3 really powerful tools in our toolkit: clustering, outlier detection, and latent variable models. So the big question is, how do these things actually work together in a real-world scenario?
Let's dive into a case study to see. Imagine a company with almost 1,000 online travel reviews. In each review, people rate 10 different categories, everything from restaurants and museums to beaches and parks. That's a lot of data. So, how can unsupervised learning help them make any sense of it all?
Well, first up, they probably want to ask a simple question. How can we find groups of travelers who like the same kind of stuff?
Clustering, of course. The algorithm will just automatically group reviewers into segments. You'll get your foodies who always rate restaurants high, and your history buffs who are all about museums and historical sites.
Okay, great. But what about that one person? You know, the one. Their tastes are totally different from everyone else. Maybe they only ever rate juice bars and ignore everything else. That is a perfect job for outlier detection. It'll flag those unique users right away. And they could be really interesting. Maybe they represent a new niche market. Or it could even help you spot fake reviews that don't fit any of the normal patterns.
And finally, what if you want to understand the bigger picture, the hidden themes that people don't explicitly state in their reviews? You know, is there a hidden preference for, say, outdoor activities that links people who rate parks and beaches highly? Or maybe a nightlife theme that connects dance clubs and theaters?
You guessed it. That's where you use latent variable models. They are designed to discover those hidden concepts by seeing which categories tend to get reviewed in similar ways, and that reveals the unstated preferences that are really driving what customers decide to do. So you see, from creating customer groups, to finding those strange but super important data points, and even uncovering hidden ideas we can't see directly, unsupervised learning gives us this powerful toolkit to find structure in the chaos of our world. Which leaves us with one final big question. What hidden patterns are just waiting to be found in your data?